Okay. How many of you are working in the AI field? Like, here's your hand. Okay, cool. Nice. Let's dive into it. Okay.
So I think Fatima asked one of the few questions. So I think few of you are familiar with agents. Anybody using Semantic Kernel? Okay, good. Okay, good. Not you. It doesn't count, which is good. So what I will share with you, this space is moving so fast. So I thought we can start with an introduction and also a vision, right? We're seeing a lot of how to build agents, what are agents. So this is a lot of kind of still theoretical. There will be a lot of announcement in build, but we wanted to share on how Microsoft is thinking about this whole agent space, right? So this will give you an overview. I'm not going to spend too much time on it. So I have a lot of content. So maybe we even would have to do part 2 next week if the organizer are okay, because I have a lot of content to cover. But we'll see. I'll try to time myself there. So this is how we think about, the latest innovation that happened in the AI space that made us talk about agents. Agents in software have been for, decades. But I think what happened with the latest breakthrough in LLM, especially in the reasoning model, the O1, the DeepSeek, the O3, the O4, is that we have seen that now agents have the capability, or, the LLM applications, if we start from the beginning, started being able to kind of understand the intent of the user with this reasoning and do the right things, right? Because if you build agents, for me, the core thing of agents is the automation and the ability to do something with natural language, right? So you have to properly understand what the user wants and call the right thing, right? And how we think about it is that, when you think about LLM and what's happening with the agent is that when you think about all the applications we have, right, buttons and clicks and menus, is because we were not able to talk to the machine in natural language, right? That's why we replaced them with button, click this, edit this, remove this, I want to do this. But our vision is that the LLM and those agentic space will be the actual user interface, will be the voice. We all want to do something with our voice, talk to the machines in a natural way. Maybe not all applications, but a lot of them, right? And this is why we see a lot of kind of traction when it comes to voice and real-time interactions with the users. People love this, right? This is how we communicate. We don't communicate through buttons and of course, to do this, you have to do proper reasoning, as I mentioned, plan the thing. This is what humans we do. We plan things. We don't just jump into kind of solving a task. We take some time, depending. Some of us jump right through in things, and then they have to retract and do mistakes. And then the memory, right? You have to remember that I had a discussion with Cher. This is what he told me. This is the context. So when he calls me tomorrow, I'm not going to tell him, who are you? What did we talk about? So there is some kind of memory we have to store our conversation with the machine. So this is kind of the three kind of main topic. And if we look back, so if we call this season 1, what happened in the last year and a half or maybe a year, it was all about conversationally and chat with your data. This is the ChatGPT experience. Every customer, every company wanted to have the same experience. I want to chat with your data, my data. It was about personal productivity. I think we're all of us here using ChatGPT or Copilot or whatever tool, like at least once a day, if not 20 times a day, like myself. There was a lot of emergence of AI. We've been pitching. I was with another cloud provider before joining Microsoft. We've been pitching a lot of AI, but AI is hard to build in the past, right? You have to spend 3 months to 6 months planning for the data, 3 months doing the AI model, training it, iterative. So it was really like when people talk about AI, very niche customers had the ability to do it or had the need. It's about Microsoft, it's the Google, it's the Amazon, because they have billions of data points. And for them, it was not even possible to do it humanely. That's why they invested in it. But a lot of us who small company SMEs, it was like, it's nice to have and never reached. So with the Gen AI, we saw a lot of use cases we were not able to do were unlocked with the Gen AI wave. And what happened also very quickly, cost of AI went down drastically. I don't know if you noticed, now the price per token is very low, which is a good thing because now we can do more of the use cases. We don't have to select because the cost is prohibitive. And it's important also for the reasoning model, right? Because those LLM, when we talk about reasoning, is they actually talk to themselves with tokens, right? So there's a price there. It's hidden for us. We don't see. We can see, but it's theoretically you're not supposed to see it. And this is why it's actually very important now to think about the reasoning models. And it's more accessible. We have so many vendors, Azure OpenAI, we have Google, there is a lot of space there. And then the season one was really the first movers, the people who jumped in quickly. I think as Microsoft, we're proud because as a big company as ours, to do the Copilot story was actually bold when you think about it. A lot of companies, big companies, they don't like to risk, we need to make sure it works 100%. And I kind of like the approach. I come from startup experience, so I like, taking risk, people making fun of you because your bot said something stupid. This is the price to pay. But I think this is the first movers. And now it's more about, everybody, every CIO, every CTO has a Gen AI and AI on their agenda. Not even then, even CEOs now had to have. The problem with this is that talking to customers is like, everybody wants to have 200 use case, 300 use case. So there's a lot of what we call use case fatigue. There's so much that can be done. When you talk to vendors like us and you ask us, what can we do? We tell them, well, you can do everything. And we show you 200 use cases and people just get overwhelmed. I think there we have to kind of really focus on the top ones, get started, get the learning, etc., and not get into this analysis paralysis. Season 2. So we left on use cases on the previous season. For me, this is a very important one, right? Because what happened is that we talked about the first one was a chat about your data, external use cases with your customers, support agents. And then it moved to, can we use this to actually reshape or change the business processes, right? We had a lot of industries and companies, I'm not sure about you, but we have a lot of workflows that are kind of, linked, and some of them are manual, some of them are automated. And for me, the manual thing, if you think about it, it's usually because there is unstructured data and text. And this is where the Gen AI shines, right? This is where we can reshape existing business processes using Gen AI. I talked about it already, but the reasoning models are kind of game-changing, multimodal, of course, and agentic, right? I think because of the reasoning, because of this kind of reshaping every business process, everybody is talking about agents, and hopefully this is kind of the core of what we're going to be talking about in the next hour now. So this is just to show kind of where we think about reshaping every business process, because I want you to go out from this session also thinking about this and not just as an external user. Do you have any use case internally where there is unstructured data, where you have to check documents? And today it's a manual step. Because of that, with Gen AI, we can change this, right? I'll share the slide after. So the recent releases are also very important because it's going to the right two directions. So we have the GPT kind of 4.0, the 3.5. This is we're still keeping in Azure OpenAI is kind of the models you use for simple tasks, for things that are related to where you need lower latencies, etc. So the key features is longer kind of GPT 4.1 now announced like a few weeks ago. We have longer context input. There's a better instruction following when it comes to the prompt and how we are trying to get the LLM to behave. And then we have the series, the O series. So Azure, OpenAI, and OpenAI specifically really need to get their name in kind of properly. I think Sam Altman promised this summer they will work on it. But I don't know if you remember, but this was called GPT 4.0, and then this is O4. They skipped the O2 because of some kind of other competition that is already called O2. But I think we have to do better naming. But think about it now, it's simpler. O series is the reasoning models. And then the GPT 4.1 and etc. are like for the normal traditional LLMs we are accustomed to use.
And the GPT 4.1 is multi like input, image, voice, everything like it's
yeah, exactly,
right?
Exactly, yeah. But we're also, what we're doing is that we're splitting also some models to make them more specific to specific use cases. So for example, before we had the GPT 4 audio, which did audio to audio, audio to text, text to audio. So, but it's actually costly, right? When you think about those multimodal models, you have to do all those kind of modalities and output. But people, for example, want to do just transcription. It's very clear. I have an audio and I transcribe it to text. So this is why you will see if you go to the Azure OpenAI kind of AI Foundry, you will see now transcribe audio. So we're kind of also separate them if you really need the use case to be separate. So what are agents? I think few of you, anybody wants to kind of, what's their view? Or I think I saw some hands who said they are doing agents. What's the core thing for you in an agent or comparing to traditional software?
So normal models are much more foundational. So when you ask a question, they are giving you more generalized answer. So they have information about lots of subject, right? So in agents, you're narrowing down the scope.
Okay.
So
But in general, like in software engineering, if you talk about agents or comparing to RPA or like a normal workflow or a web job, that's what I meant.
we define it as task.
Okay. But what is it different? Like we have tasks, we have automated tasks. What is different now with the LLM? So it's good. We have automation, which I think is important.
That's just the user's intent.
Okay.
Possibility to reason to a certain level with autonomy.
Okay, good. I like autonomy. So we have automation, we have intent to user, yes.
Planning the user profile.
Okay.
Building based on the forms.
Yeah.
Building a user profile and understanding the context to deliver
Yeah.
more personalized output.
I think it's those keywords are all there. But we don't have to be pedantic. What is an agent? What is not? I think the most important for me is it has some sort of natural language kind of interaction with the user, because we don't have to hard code things, right? So people can ask it in different ways. They can, if you imagine like an interaction with the data warehouse, right? Usually we build dashboards with predefined graph, right? But with an LLM or pseudo agents, I can ask whatever I want, right? As long as the data there, so the user, depending on their profile, I don't have to build anything. I just let the LLM decide on how to interact. And that's why we're like on this graph. So instead of saying agents, no agents, I think there will be kind of a grading. You know, agents 1 can do 1, 2, 3, etc. to more advanced things. So we can even say that the first LLMs we built chatbots are agents, right? They interact with the natural language interface. They might reason or not. The middle one, more advanced. They can retrieve information about the user, about the context, about the question. But for me personally, I think the cool thing why now it's really exciting is this, right? Is we want to automate. I don't want to talk to my bank agent. I want to just the agent to chat, transfer money. I want to go to Qatar Airways, change my booking tickets. I want to do those things through the agent, right? And this is now kind of where we're going into the industry. Can we automate some of those actions? And this is why natural language interface, kind of automating, using reasoning and planning, doing its own thing, and then taking an action. And I think this is like if we divide it in from 1 to 5, this is the 5 agents where it's completely automated.
Or just partial automation where you have the agents, they give you recommendations, and then it's up to you now to decide what to do.
It could be grade 4, right?
Yeah,
Human in the
because-
loop, that it gives you the plan. Yeah, exactly. That's why I don't want to say between non-full automation or full automation is this is an agent. We can decide like, you know, level 1, it does only generation. Level 2, it retrieves information. Level 3, it gives me the plan. I'm going to do this. I'm going to update this database record. I'm going to delete this. Are you okay with this? Press 1. Level 4, go for it, right? Or maybe half of it. So it's going to be, I think, a mix. And we don't have, again, to be pedantic about it, as long as we, you know, we're doing some natural language interface, there's some autonomy. Because if we don't have, like, if we remove those things, if we remove language interface, we're back to kind of buttons and links, right? If we remove autonomy, we're hard coding things, we're back to normal. And if it doesn't take action, what's really the point? Right? Yes.
RAG and agentic RAG?
I personally have an issue with that. I think RAG, as we know it, should be very fast. You take a query, you change it maybe a bit, go to a vector database, get the document and pass it to the LLM. What I've seen with agentic RAG is completely different, whereas for me, it's a different thing. It's really trying to use the LLM to almost massage the data, get new data. It would use RAG, by the way, so it will go to a vector database, then call some LLM, do some tweaking. So for me, calling it agentic maybe is a bit of marketing thing, but it can be useful for some cases. But I don't think it's either or. So I think this summarized kind of the thing. So today we can have, this is where we had RPA. We could have some kind of tasks that are automated. We had chatbots, right? We tried to make the chatbots do the right thing with the bot dialogue flow. It was very painful, right? If the user says something different, we are all lost. I think a lot of customers want to get here. But for me, like the summary, I will have it in the last slide, but I want to say this. I think we need to get this right, like get the learning, get the kind of experience, maybe choose a workflow where it's not going to be a lot of damage. If you go to my example of Qatar Airways changing tickets, that's maybe last thing you do. Maybe you do something internal first, get the first agent there, do its evaluation, do its tracking. We have so many pieces we haven't really figured out. And people are talking, how do I kind of navigate 100 and 200 agents? But I think it's important, right? But I think now, like, I don't know how many of you are developers here, like not AI, but developers. I think it's a really good time for us. I'm also a developer background. Because now I think the LLM are so good. I think the innovation would be in very top research labs, but the thing that will be on the ground is how to make them like in a successful application, right? So I think the developers is back kind of to the main stage to make this work. Because how do you trace this? How do you debug this? How do you update this? There's so many questions that, we shouldn't forget about the traditional software engineering practices we learned for the last 50 years. Thinking that it will be just magic. So if we summarize again, agentic capability, so the agent will have a lot of things, it will have tools, has to do things, can search, can execute code, can calculate, calendar, etc. Can take actions again. It has to have a memory. Again, you need to remember, what did I say yesterday, what happened, who's this user, sorry. And then this is also very important, right? I think this is why the reasoning model are important, because I have to do plan. Like if you tell me I need to onboard this employee, I need to know, oh, this is a new employee. No, it's a returning employee. Do they need a badge? Which location they are in? So there's a lot of things that can happen in the background. It has to do decompose, maybe collaborate with other agents. This is where we talk about multi-agents, etc. But I think this space is still evolving a lot, right? That's why if we focus on simplicity first, getting the first agent right, and then evolve as we go. Oh, so this was just an introduction, right, to the content. So Microsoft, how we're seeing it is that anybody using Copilot Studio today? Okay, great. So Copilot Studio is our low-code kind of platform to do agents, apps, etc. And we have this on Azure AI Foundry. So we have two kind of flavors on how to do agents. I think we believe there is a big value in, again, doing one single agent right. And this is why we have this managed kind of service called AI Agent Service, which I will cover in more detail. And then we have build your own agent kind of thing with code, etc. And there we have two frameworks. So we have AutoGen and we have Semantic Kernel. So you might ask, why do you have two? Answer, why not? But no, it's different teams, right? So Semantic Kernel, how it started just as a normal LLM, like LangChain. I need to do embeddings, I need to do chunking, I need to call the LLM. AutoGen started as an agentic framework, right? Before it was like mainstream, it was like a year and a half ago. I remember when I joined Microsoft, some of my team told me agents will be the biggest thing in the next 5 years. So this was a research team. How do we do agentic things? So now those teams collaborate very closely, and we have a lot of patterns that we learned from AutoGen team into the Semantic Kernel. So 3 or 4 weeks ago, the Semantic Kernel agents became GA, very recent. And again, this is production ready. So this is what we recommend in production. If you're a customer, go for Semantic Kernel. If you want to try, if you have a research lab, you want to try different patterns of communication, etc., go for AutoGen. It's good to know what's happening, but I recommend to kind of play with both. So for Semantic Kernel, I recommend also we have like an office hour every Wednesday at 6 p.m. on YouTube. So you can join this if you're interested. You can ask your questions. It's an open source, so you can also contribute if this is of interest. So, this is our kind of learning Microsoft working with customers. So single agent system can do a lot of cool things. They can do multiple tools, use data sources, of course, for grounding, low complexity, and very easy to deploy. I'll show you the agent service. We can deploy one in a few minutes. Multi-agent system, of course, as any software, right? That's why I said we always need to come back to our software practices. Nobody goes for microservices just out of the box. Let's build the Kubernetes. Let's divide the application. We all know the pain to communicate, to update, who's doing what, etc. So that's why people usually start sometimes with monolith, and as they grow, they divide them, right? This is my view. I think we need to think about it the same way. Start with one agent. Then when you see that it's doing more than one, the single responsibility principle, start splitting it out, right? And I think by then we will have better tools for tracking, communicating agent to agents. So higher complexity, harder to debug. So again, use it where it makes sense. If you really had the kind of the software practices in place, go for it. And if it solves your problem, of course. And also something that I'm excited about in Semantic Kernel. Again, instead of changing everything at once and it's like, oh, let's build everything as an LLM. So what they did is they added something called the process framework. So again, those business processes we have, like this thing, and then this thing happens, and this. So in Semantic Kernel, you can actually, what is the word? You can design it with the process framework using this. And then maybe you have one agent in this 18 steps. Instead of going all in, start slowly. That's why it's about freezing things that work and then don't need an LLM or a Gen AI application. And then replace things that would benefit from reasoning and agentic stuff. Yes.
Multi-agents. Usually there is always an orchestrator agent, or like it is all are dependent and they just like doing in a mesh type of world, or there is always some agent which is just orchestrating the task to other agents.
Yeah. So again, on paper, you see different patterns. You see the orchestrator pattern, deciding which one to call. For me, I think every agent will have kind of an ability to have a planner inside, and then it can decide, I have my tools to do my own job, or no, I need an external agent, an external service to do this for me. But it's, again, an evolving pattern. You can do all of those. Ahmed, you had
regarding like the use of single versus multi-agent, I don't really get why we need multi-agents. From my understanding, the agent, what it does is you have maybe, let's say we have 3 functions, one gives you red, one gives you yellow, one gives you blue.
Yeah.
And I tell the agent, give me magenta. It's like blue plus red, gives you the color. Why do we need multi-agent since you can just give it all the functions, like, okay, do everything?
Yeah.
Does the agent get overwhelmed when it has multiple functions that do some different things? So you try to separate them by category, maybe?
Yeah. So that's a good question. Thanks for asking, Ahmed. So again, coming back to software engineering, imagine we're defining a class or something to do. So what we're saying, we can have one class that does everything, right? So let's say onboard employee, right? I know we shouldn't name class as a verb, but imagine this is like when a new employee comes in, we have one agent or one class. So this one, for example, does HR stuff, needs to update their record, needs to notify their manager, needs to do payroll, etc. Then we have IT. They need a laptop, they need access to certain system, etc. Maybe they need visa. Imagine this is a visa thing. So in software engineering, we're now in agentic space, somebody might look into this. Yeah, it works, of course, I can do this. But this has so many responsibilities, right? It knows about HR, knows about IT. Those guys might not have the same API, they might not give you the same access, etc. Visa is completely, we work with EY to do this. It's not even in our system. So yes, it works, but this is why I said, start with one agent. And then when we see that you're doing HR plus IT, you're like, oh, maybe this is time to split. Maybe IT will actually develop their own agent. Because they don't want to give you how they, change requests or permissions or how they order laptop, right? And then we start into the multi-agents. To onboard an employee, as Cher said, maybe we have an orchestrator. And then it says, hey, it will send a message maybe to service bus, says we have a new employee. And then this guy does its own thing. HR, the IT does its own thing. And then the visa thing does it. This might be like up and down. This might be completely automated. And this could be even bigger as well, right? Imagine a bigger system. This is also just another orchestrator for HR because we have multiple agents, right? So as you see how big it can be in big enterprises.
For security or?
Security, maintenance, because again, like imagine this becomes like 500,000 line of code. It becomes really hard to debug, to change. Maybe it's different teams.
But it's the same risky, no? It's really risky to have multiple, you can train multiple agents, a lot of work.
Yeah, I agree. That's why it says higher complexity. If you don't need to do it, start with one agent. But then when you do so many of things, like imagine this is one file or two files shared by 60 developers. I don't know if you worked with 60 developers on one file. Nobody wants to do this, right? Just thinking about the merge conflict you will have.
Sorry, I have a question. Earlier you mentioned that the agents require sort of a memory. Is it like for storing or processing? Because it's becoming more of a computer itself.
Yeah.
Is it like similar to the RAM or?
Yeah, it's a good question. So it's both actually, right? So I'll cover it when we go into the slide, but it's both. So you'll have the short memory, the conversation I'm having now. Maybe I need to store some of it. Even then, because I don't want you to ask me again tomorrow for my name, right? Or imagine this one is a memory, like there was a bug and we want to make sure that, Bell didn't have the machine, so we have to store it somewhere. So tomorrow when it starts, it knows. Yes.
In terms of what you have described here with the orchestration layer, I'm aware of two tools existing on the market, N8N and Make as well.
What is it? What did you say?
To something different.
What did you say? What is the name?
N8N.
A and N.
N8N.
8 N's. What do they do?
They orchestrate different workflows, also integrating, for example, agents or simply API of tools that we all use, like WhatsApp or any other other sorts. So what is the orchestration on which kind of tools would you refer to in this kind of?
So I don't know them exactly, but what I know, for example, one is we work with those guys, right? They do a lot of RPA, etc. So they have the same question on their tools, right? Everybody is looking, how do we become also agentic? How do we enable our application to be Gen AI? So I'm pretty sure those guys are doing the same. Maybe you can integrate their agents. I think we'll talk about it at least on the Azure, on the Microsoft way on how we think about the integration. But I don't know those things. So what I'll show you today is the vision of Microsoft. And I think we will have also agents. You're seeing what happened with MCP, with the A2A, how do we agents expose? So it's a lot of things. I don't think people have answers yet, but definitely everybody is thinking the same thing. What's going to happen to me? What should I do to Yes, please.
Just to add the process automation, there are already tools which do process automation or workflow automation. Okay, you'll have Microsoft automation as well, but you need to have a strict type of automations. First do this step, then do this step, then do this step. Okay. Consider that the flow is so complex that you don't know which part to take. Because consider you have n nodes, okay, and you want to connect end-to-end nodes. It becomes an exponential problem. So if you do the automation in those kind of tools, it will never work. So this kind of tools or this kind of automation will think automatically and you don't have to connect the nodes explicitly. So that is what I think is the difference, that the process automation, which is like a mature industry, where we have like from IBM, you will see it, from Microsoft, you don't just do the automation, but these agents will make it simple because the complex task will not be able to do it with the existing automation tool. That's how I see it. But as Mohamed was saying, it's changing, right? Like there is so many things that is fluid that we don't even know.
Yeah, because those guys, for example, they see themselves as threatened, right, by the agentic space because of he's saying it's hard coded, it's very limited. You have to go and change. Where this is like you can add just another agents here and expose it to the orchestrator, and it will do new features without you having to do anything.
It's constantly evolving. Just to add, I'm using an automation tool myself.
Which one is it?
It's called Make, actually.
Make,
It's a
okay.
German tool.
Okay.
And it's just thinking of the addition of different APIs one-on-one, like one after each other.
Mm.
You can go and add just as much as you are creative and good with that. But at the moment, what they have just released about a week ago is the integration of agent inside those kinds of workflows. So they are also trying exactly to be part of.
Do they have the over low code to build agents, or how would you? What kind of agents can you integrate?
Yes, that's what I need to get started with. So I haven't tried this capability, but I know it's just got released about like.
Okay, different. She was first, and then.
Group agent Autogen?
Huh?
Same as a group agent of Autogen?
It could be, but I will show like the AutoGen one is called the group chat.
Check.
Yeah, exactly.
Same as like moreover the coding or just a flow, like drag and drop something, predefine things, or it's like a group agent?
It's more like which one? This thing here? This is more different. This is like a more orchestrator that can just decide that I need to call this and this. Whereas a group chat, you have all of them participating in the discussion, right? But I will show you like in Semantic Kernel, if we reach the time, on how we do kind of selection strategy of the agents and the flow of those. Do you have?
Yeah, so my question is much more related with the design architecture. So
Yes.
in software engineering, we have some principles like clean code. So in clean code, every function needs to have one single functionality. So when we are designing agentic architectures, does an agent we need to narrow down the scope of the agent to just focus on one single task, or do you prefer designing more general architecture?
So if you think about it again, like agent for me, analogy is a class.
Yeah.
So a class can have 20 functions, but it's one single responsibility in one domain, right? So it's not about one agent, one function, but in a domain, specific domain. So it could be an HR agent, an IT agent, a visa agent, right? And then they have 20 things to do inside that are public methods or functions.
Maybe it's like domains.
Exactly.
We are doing in the microservice architecture. So you will define the domains, subdomains, boundary context, and then that's the agents.
Yeah. Actually, we're in one of the accelerator we're doing exactly this. We're thinking the same space into microservices, a domain. I have my own database. I have my own knowledge. Then I expose things, the agents being here. We're using Dapper to communicate with, service bus. So that's why I said, like, it's really now back to software engineering to really make sure we deliver this into production. So again, I think we agreed there's a lot of challenges from one to fleet. But this is where we're thinking, this is where if the industry is thinking. So we need to have an end user. Is it a UI? So in Copilot Studio or in Teams or Microsoft Copilot, now you see a lot of agents there. You can select one way you want to work with or talk to. It could be an API. It could be another protocol. I think Google came with something called A2A. So it's space like how agents communicate to each other. Anthropic with MCP on how we can expose things to the agents, tools and functions, etc. We have to have an orchestration layer for the agents. How do we create them? And then, of course, the trust, who can access what are we giving to, etc. So again, this is all theoretical, right? There's nobody who's providing all of this. But I want you to think that this is a lot of things we have to fix. But it's in software engineering, right? A lot of it is just how do we communicate? How do we expose things? How do we make sure we're calling the right things, having the right access, etc. I'll speed up because we have so many things to do. So again, potential architecture, very theoretical, right? Some of things we have already. So we're going to be using a lot of Azure AI Foundry, Agent Ops or whatever. And it's about CI/CD. You have different ways of exposing agents, writing them. You can do it through Semantic Kernel, AutoGen, LangChain, whatever you choose. This is just the framework. AI agents is something we do in part 2 and part 3. So this is something in my team, we built like a wrapper against Copilot Studio agents. So this is why it's an end-to-end. If you have like business users who know how to use Copilot Studio, you can actually communicate with them in Semantic Kernel and use them, reuse them. right? And it could be third-party agent. Let's say you need something from SAP or from Oracle or from Databricks, you can involve that. So then this is the building things, this is the cooking, this is the kitchen, and how we expose it. It's the agents, the common interface I talked about. How do we expose those agents, right? Still work in progress. And then we might have private registries, like we have Docker registries. You can have public registries of agents, etc. And then do we expose them to the user interface or through APIs for others to build on top of, right? So this is, I think, what I talked about. I'm very pragmatic, so I send these messages in my conversation, start simple. I think I still have to see somebody doing one agent properly in production. So let's not think about multiple. We have to keep in mind, right? Because we need to build maybe for scalability or just for our learning. Maybe we influence the direction of how things are going. But let's build that first small agent that does things. Again, it's about this. Why do we start simple? It's about getting familiar with the tools, familiar with the technology, the limitations, and then scale from there, right? In the beginning, you might have 10 agents, but they don't talk to each other in the beginning, right? Could be cool if the HR had their own, IT had their own. And then when we figure out how to expose them, how they talk to each other, we'll be exposing things maybe internally for people to build on, similar to APIs, right? Agents might become the future of APIs, that we expose agents and then people kind of group them in a nice way and build new workflows that you haven't thought about, etc. Okay, this was just the appetizers, right? Like now we get to the real content. Now we are all on the same page. So I will maybe spend less time on slides and then go to the notebooks. 8 p.m. We have to at 50 minutes. So how do we do this? So we do 20 more minutes on agent service. Maybe 15. Okay, this should be simple. So you remember when I showed how to build agents, we had two ways. We have the single agents. Why I like this, it's kind of a serverless from a backend for you guys. You don't have to think where to deploy this app, how it calls function, how it does vectorization. And we take care of all of that. So it's very simple. In 2 minutes, I'll show you now. We can show you how we do this. So again, we provide knowledge. It can take actions. Security, it's in Azure AI Foundry. So all the airbag you have already in place will work for the same thing. And then, of course, we have something in Azure AI Foundry. To be honest, I think there's a lot of work to be done here. But I want you to think about this evaluation. It's still an AI project, right? I think with Gen AI, we started jumping into things because we think it's magic and it's going to work 100%. What happens is that we start getting the hallucination. Oh, it's not giving me the right thing. I'm changing the prompt. Oh, how do you know what you're changing is actually making sense? This is why we have to, again, it's still an AI project. So before jumping in, let's say I'm doing my HR thing, get your data set. Like, how are you going to validate that it's working, right? So for me, I'm pushing more and more towards this. Let's think about them as AI projects because they are actually, right? I think we forgot. It's so good that we forgot. So this is in public preview. Again, I'm not promising anything, but there will be a lot of announcement in build. So hopefully this will become GA, but for now it's preview. So it's about, again, rapid development. There's a lot of extensive kind of data connections with existing AI search, with Fabric, with SharePoint, etc. You can select whatever models you want, as long as they are, you know, the model as a service, GPT-4o, Llama, Mistral, etc. So let's not spend too much time on here. I'll show you in a demo in a better way. So again, how they work. So again, we're all familiar with this. So nothing magic except that it's kind of serverless. I want to book this. The LLM knows what you're talking about. It can get fetch some knowledge source. So this is the RAG. We still need it. It's calling the LLM to kind of fetch the answers and customize them and decide if I need to do something. I need to send an email. I need to send or fetch something, right? So under the hood, how the agent service work. So you create an agent, and an agent can have multiple threads. So it could be different discussions with different users. So the agent does something. So I have an instruction here for travel agents. I selected my model. It could have data or not. The example I'll show you two, one with data and one without. And then this is the tools that we kind of have to call. So this is where it can take action, right? So the 5 search is basically this. So it does AI search, but it does it in a managed way. So when we do this and you go to your AI search, you will not find it. It's managed by us, so it's completely serverless. Again, for some of you, it's not a good idea because I want to manage my data, which makes sense. This is why you would use AI search instead. So here I'm just creating a thread. I'm asking a message. I'm asking a question. Can you book a hotel for me? It can go to an API to check for hotels, create a message. This is the LLM returning the message to me. And then I can have, what is the daily allowance? And this is kind of using SharePoint connections and giving me the data out of this, right? So again, it's automatically, sometimes it's calling functions, sometimes it's kind of doing file search or data track. So so this is still not there, but it's gonna be announced in build or it's coming soon. This is really good because I don't know if you have, anybody has Logic Apps? Share, you don't count?
Maybe we should introduce what Logic Apps are.
Yeah, so Logic App is actually pretty good. I'm not a big user myself, but a lot of colleagues who are using it, so I'm getting more hooked because it's very kind of a low-code drag and drop to do a lot of things related to sending emails, connecting to CRM. There's like 1,400 connectors, so you can do a lot of things without really coding. And the cool thing with here is that you can reuse them in the AI agent service, right? So the one we have most of the time is sending emails to Outlook, which is very, if you had to do it in code, it would take you a couple of days.
It's like Power Automate for those of you.
Yeah. Anybody using OpenAI API to declare APIs internal? Nice. So if you have any internal in your organization, you can import them directly here through the schema that you have. So a lot of reuse. And then on functions, you have 2 ways. I'll show you one way. So you can use Azure function again, whatever you have infrastructure that you can reuse, or you can build ones through code. So in my example, I'll show you the ones through code. And this one, I think we can skip. Grounding through Bing. SharePoint is coming. It's private preview. Unfortunately, the on-prem one will not be supported. It's going to be just the online SharePoint. But if you have that, you can link it to the AI service. And this one we will cover. Yeah, and this one I think we can skip. It just says that you can do multi-models, etc. Even if you do fine-tuning. Anybody doing fine-tuning? Nice, so you use your fine-tuned model here. And the most interesting part, but it's going to be very short. It's quick to do this. I promise rapid development, right? Let's see if it works though. So where are you? I think it was this one. Okay. So what you need, can you zoom in? Zoom in, okay.
Control. I think Control plus.
Control plus, where's the plus? Okay. Okay. Let's close this, we need it. Okay. So the most important thing or the new thing here is the new kind of dependency on Python. So AI project clients and then the models. So here I'm importing what we call a function tool. So this will wrap like whatever functions I have existing in code. So in code in the UI, you cannot add functions. So all of this has to be done through the SDK. And then whatever tool you have. So as we saw in the slides, we had Bing, we had AI search, anything of those things we call tools. And this is basically just a business kind of a Python normal code, right? So since we're building a travel agent, I made few functions. So imagine this exists already in your system. So there's nothing specific here I changed except this, right? So for the LLM, we have to kind of tell it what we're expecting, what this function does. etc. And here I'm just baking, like this could be your API, proper API to your whatever system you use. But here I'm just hard coding for the demo. So what I'm doing here, I have one to fetch flights information. I'm having some hotels, and then I'm booking, right? I need to book some flights and book some hotels, right? So we go back here. So here I'm just creating the project. So I don't know if you're familiar with AI Foundry, but we have a Foundry, you have a hub where you do all of your connections to AI search, to the LLMs, and then you create different projects that show those connections in the hub. So the tool set, that's all I have to do. So since those are functions, right? We did some functions to fetch information about hotels and booking and flights. I'm wrapping them in this function tool. I'm creating a tool set, and I add my functions, right? So let's run this actually. Should be runnable, sorry. And then I'm doing my credentials. So this is, I don't know if you're familiar, but we're moving away. Most of the internal things, we don't have API keys. We use this type of credential to log in, which is kind of safer. You don't have keys around laying around. It just uses my identity or the service when you deploy to Azure.
So doesn't it fetch from your environment variables?
No, it's like when you do AZ login in my Visual Studio Code, that's how it knows who I am. AZ login. So if I'm not logged in, it will not work. When you deploy this, you use a service identity to get the identity. So the same code works for either a service calling this or you, a human, right?
You're also going to be able to define it on your Docker file, right? So when you productionize it.
No, that's the whole thing. You don't want to do API keys or anywhere, right? Just to get rid of that. So if I'm a service, I get my identity and then I call an API. It uses the service identity to know, okay, I have access to this or not that, right? So, and then we're back to our normal things we're used to, right? So I need instructions. So I'm telling the assistant or the agents that I have access flights, and this is the methods they can call, etc. Let's run this. So here what I did, nothing, right? This is just a Python thing that I'm gonna be reusing. And then with this simple stuff, so projects, agents.create agents, I give it the model name. So this is, I got it from the environment variable, so I'm gonna use whatever model I have. The agent's name, again, I just hard coded it, the instructions. So this is the prompt, and then the tools. This is what I can call. I can call functions, I can call Azure functions, etc. And that's basically it. That's all you need to create your agent. I had some that are already created here. So I don't know if you're familiar, but it's here. So this is the AI Agent Service. So here I just created one now. So this is same. So you see the tools that it has, you see the model that it's calling, and when it was created. So of course you can change this. If you made a mistake on the prompt, you can change here. And the knowledge, you can do some of it here manually. Sorry. So here, this is all the agents I have. And some of them, for example, if we go. So this is the thread. So this is if you want to kind of debug and go to the history of what happened, what did the LLM answer, etc. So I can come here so you can see the conversation I had before. See something first. Yeah. So in here you can see this had nothing. I will zoom again once I get my line. So here, I'm asking it to book a flight to Dubai. It was not clear. It was actually asking like what's the return tickets, when the date, and our airport code, passenger details, how many passengers do you have, etc. Return, then this is me confirming, etc. So you see the idea, right? So it's about really easy of creating agents. I can create one here directly. So it's created. I can change the name. I can get the deployment and the instructions, right? A lot of things can be done here. So I can upload files. So this is what I said, like we have a managed kind of environment for data. So if I had a PDF or information about HR, I can upload it here and we do the vectorization for you in the backend. If you don't want to do this, you can use your existing Azure AI search, right? In a production environment, I would go with this. I know my index. I can control how I'm indexing my data, how I'm chunking my data, etc. But for testing, quick testing, this is really good. And then Fabric, etc. This is for the knowledge. For the action, as I said, like this is done. The code interpreter, I can enable it. Or if I have an OpenAI 3 specification, I can upload here. For the rest, it's through the code I showed you, right? It's mainly a few lines to add that. So we're back here, right? So what I want to show you, it's the same example, but a bit more advanced on what you can do, mainly on debugging, logging, etc., which is important, as we mentioned. So here, the differences now is going to be, see, I'm importing more things. I want to see what's happening with my thread messages, the run, the delta of the chunks that I'm getting from the answers. So same thing for the functions. Same thing here, nothing. So here we're doing something different, right? As you see, here I'm uploading the data that is I want to book a flight, hotel, and then get some cars. So car here is an example. I did it through a JSON just to show you the capability if you want to vectorize something. So this code is actually, we can share it. It's public for you to look at it later. So here I'm getting the list of vector stores. Those are the managed ones, right? Those you will not see in your environment. This is in a Microsoft managed tenant. And we are trying to see, for me, do I have this? Do they exist? If not, I'm going to create it. Otherwise, I'm going to reuse the same. So let me run this code as well. I want to show you the. So here's working. So I'm just getting my credential, creating my projects. So this is also just a tool, right? A search tool. And here's nothing fancy, actually. So you see, I'm not doing any vectorization or any embedding. It's taken care of by the service. I'm just uploading my JSON file. Right? That's all I'm doing.
Uploading to where?
Huh?
Uploading to where?
It's a managed tenant we have backend. Do you not see it in the Azure port? And then basically I'm uploading it and I tell it to create a vector on top of it. So that's all I need to do, right? Once it creates it, I tell it to create this search tool. So remember, we had tools, functions, all of those are called tools. So now we're going to combine them into the tool set. So here it's just this is just a utility function or a class that we're inheriting from tool set to show you here, like which functions, what are we trying to call in the UI later, that we're passing the right parameter. Again, very important for debugging and going into production. And then we just call the super.execute tools. Again, same thing for the function. I'm just wrapping them in a function tool. And then instead of creating tool set, here we're creating logging tool set, which is basically just adding this. Nothing fancy here, right? Blah, blah, blah. Then we run this. This is also some debugging things to show you which tools we're adding. So we're adding a file search. So this is where the vector and text. And this is function call. And in the functions, how many functions do we have? We have 4. We have fetching the hotel information, flight information, and then book the flight and the hotel. I know I'm obsessed with flights, and because I would love this to be automated, just change things without calling. And I think it would be a great day once it's public stuff. So here again, this code is just to manage, like the one I showed you is kind of very raw, just trying to create the agent. Whereas here we're trying to find it. Does it exist? And we reuse it. Instructions, same thing. So if we find it, we would update it, right? So this is the code you would have in production, right? You wouldn't be recreating the agents all the time. Otherwise, the list gets really long. If it's new, just create it. Again, so you have 2 methods, update agents or create agents. So here I can update the tool set. Let's say I have a new functions, I have new instructions. I want to use a different model, so I can do it through here. Again, for me, like I know we saw you can do it in the UI, but for production, This is better. You have it in your GitHub. It's tracked. You know who changed what when. So this is the recommended way of doing this. And then we create a thread, right? Let me see. I don't know if I ran this already, so we don't get no issues. So we are reusing it, and then we create a thread. So this would be just creating new conversation. This is also just for debugging, right? So here's just to, we're gonna use Gradio for the UI, so you could use similar things. So here's just to show it in a nice way, the assistant, we're calling functions, we're calling it function with this parameter. So this is just to give us, so we're inheriting from agent event handler, and we're implementing what do we wanna do with those messages. So if you go to this guy, you will find that this has to be implemented, all those things, right? So you can implement all these things on message delta, on thread message, on thread run, on thread, on run stop, etc. It's not important, right? Like you saw the first example, it's completely runnable. But if you want to do it and integrate it in an existing UI, this is the way to do it. So you create your own kind of custom handler. Let me run this guy.
What would be the best way to find out the accuracy of this architecture?
Accuracy.
How we can measure the accuracy?
Very good question. And it comes back to me telling you, you need to think about this as an AI project, get a validation data set before you even start, right? I have 100 questions and this is the expected answers. This is the good start. Then when I build this, I can run the evaluation on top of it. Once I have an agent, I can throw those 100 questions and see if it's giving me the right answer. And we will talk about it. I don't know if I have it in the semantic kernel because we're looking into, let me see if I don't miss it. Semantic kernel. Because for agents, we're talking about new metrics on how to evaluate an agent, right? In a normal LLM, we talk about groundedness, accuracy, fluency, right? But for agents, is intent resolution. Did it understand what I wanted, right? So I have to have some data to see that for this example, I wanted to delete my flight completely, right? Maybe the LLM thought something else. Tool call accuracy, is it calling the right tools? So I'm expecting that we would have a JSON for a specific use case. I expected to call function 1, 2, 3 in this order, right? Task adherence, did the right thing? Did it complete? So this is still work in progress for the agentic thing. We're having something on Azure AI Foundry, but it's not complete.
We're also going to develop an agent to provide this feedback.
So most of those have like an agent in the back. Like if you did the groundedness or fluency, we use an LLM in the back to say, is this grounded with this data, right? So LLMs are all over the place for this. Okay.
Do we use that? I think it's called PLEU. PLEU metric. I mean, it's a, what's it called? I mean, it measures the accuracy of PLEU.
EU. No, I haven't heard of it. Have you heard of it?
I mean, it's basically.
I can check it out.
I can't formulate what's it called, but it's like a metric to measure the accuracy. I'm not sure if it's
accuracy of what, like the.
I'm not sure if it's for the
benchmarking.
Benchmarking, yeah, you need it, but it's specific.
It's a benchmarking thing. I'm not sure. I mean, evaluation metric basically.
Yeah.
So do we
There are a lot of
that for
metrics.
agent?
I haven't heard of this. I will check it out. I'll check it out.
So is this more like evaluation, or is that more like test cases and just
exactly.
cases?
Yeah, exactly. Because again, though, when you think about the AI projects, that's how we did these things, right? Like we had a training set and we had a validation set when I'm training my own model. Except that now I don't train my model, right? It's trained for me, but I still have to validate it somehow. So this is where I think when misstepped, we skip. Yes.
Yeah, sorry, going back to this point related to the testing, and I think it's also part of another discussion. I wish Fatma was here. Is from a business perspective, this does affect the QA process in a way that it identifies new indicators, it identifies new processes, meaning that additional resources are required at the quality assurance process. So in a way, how does that transcend and convince the product manager that, because to them it's just a matter of resources, you are limiting the resources here, but you're also increasing the time for the testers, for additional developers. You see what I'm saying? It's less responsibility.
Why do you think it's adding instead of just similar to software? Because for me, I would expose this as a new app to my QA.
Yeah, but for the QA, it will require more time for him, more knowledge, more indicators.
Yeah.
It might require even additional testers to do so. So again, because product managers, business managers look at things for numbers. So how to convince them in terms of the added value, like even though to them it's just the same thing.
Yeah.
There's certain care for the tester. There is,
Yeah, definitely. I think that's what I wanted to mention. I think there is some kind of retraining for our QA team on what to do, right? But I just trying to think about my own background when I was in like building products and stuff. So, you know, usually the QA, imagine this was not a voice interface or a text interface. They would have their test case. I need to click 1, 2, 3, 4. This is the expected result. So I expect this to be similar, right? They will have to say, okay, for when I say book my flight for this, this happens. So for me, it's very similar. I don't see the big difference, except that, you know, here we can automate more, or maybe, right? This is where we come back to the validation set, which people are just skipping. I think they just skip. I haven't seen like a proper customer who had like, oh, this is our validation set. I think Gen AI is expected to just do things. And then we come back into issue, oh, it's not, it's hallucinating, it's not giving me the right answer. And even when like, I don't know about you, like me changing prompts and like, what's gonna happen, what's gonna break, right? I think we skipped a step which we knew about, that you need to automate this. So this is why for me, I started a couple of customer projects. Before we started, like, hey, what's the validation test? What are we trying to improve? What are the questions? Can you give me 100 questions and then answer? I know not everybody has it, but that's how I should think about it. It's still an AI project. But for the QA thing, we can discuss it, but I don't see the big, maybe like a reskilling. But more people, I don't see one.
And also, Mohammed, maybe while we are designing our agents, you know, we can use also these templates in the system messages, right?
Yeah.
We can define these template frameworks, Fluid, or we have another one. So if we can define our agent answers enough accurate and enough clear, and if we strict it as much as possible, the answer should have a template.
Should have a template.
Right? So let's say when the user asks you a question about, I want to fly to Dubai at this day, at this time, blah, blah. So the answer should be, these are the current flights at this time frame, and then list, for example. If you give this answer as a template to AI will respond like this, right?
Yeah.
So this will make the things easier for the QA team also. And since we are talking about the agents doing the specific tasks, maybe the answers will be also strict for the role of the agents.
I think to start with, we definitely have to be strict. But for me, the beauty of this is that it's not strict, right? It's like we, like humans, we can have 20 different ways of, hey, can you book a ticket, right? This is why the previous system failed, because we were hard coding and things. And if they ask in a different way, it completely fails. Now, like, I really don't want to go back to like hard coding things. But I would say, like, if you're a project manager, I would say, like, now with your QA, they can also like use Gen AI to generate those test cases. So I think it's like everybody's sped up with this this use cases. But we can discuss it. I mean, I manage the QA teams. Yeah.
I'm curious about in your project you use GPT-4o, which is like 90 billion model, right? If I want to optimize my system and if I want to use 3 billion model, how 3 billion. How is it possible for me to achieve the same performance with fine-tuning my model? Because like what we mean with agent is that it first needs to understand the question, then it needs to plan, then it needs to action, right?
Yeah.
With fine-tuning a 3 billion model, am I achieve the same performance?
So I don't know if you read the DeepSeek paper when they released it. They had this. So it's a 67 billion parameter, like the big one, the R1, the V3. So what they did the distillation to smaller models, right? They did distillation for llamas. Distillation just means using a bigger model to kind of distill the knowledge to a smaller model, right? They've seen that it's really good. Maybe 5-10% degradation of performance. But I think when we start talking about the planning and the reasoning, it might get harder for smaller models. So we might use them for tasks where it's like about, again, summarization, simple issues. So you will have a mix. That's why in semantic kernel, I can have multiple services in my kernel. One that does the planning, maybe the orchestrator, because I need really to make sure it's a reasoning model. And then for smaller tasks, for the easy tasks, we can have smaller models, or on-prem or fine-tuned for specific tasks. So it's going to be a mix. But I'm using reasoning model all the time now because I see the huge difference. It's not like I had a use case. I was trying to get, again, F1 score, the accuracy, the precision, 60%, 70%. I didn't change anything. The prompt is the same. The code, I changed to O3 mini, 100%. I'm like, I can't go back, right? But what I recommend also, I know it's like overwhelming, even for us, right? Like so many models. So which one do I go for, right? I recommend go for the best, which is GPT-4 or 3. Get a baseline. Know what good looks like, right? It might be that you don't want 99% or 80%. Maybe it's too expensive, but at least you know what good looks like, and then you work your way there. Maybe if your business says, yeah, this is good, we want to pay for it, good. If not, okay. It's a business decision at the end. No, we're going to use 5.3, we're going to use Llama 7 billion, etc. But at least I like to have this baseline. Where are we starting? To get rid of the analysis paralysis. Because, like us and Google, we're like, oh, we have 1,400 model. I'm like, it's too much. Where do I start? Don't tell me you have 1,400 model. So I think we have 20 minutes for 2 hours of content. Are you guys free tonight? No, that's why I knew we'll have to do maybe. So what I can do now, let's finish this. We didn't finish the demo. This is basically just Gradio. I don't know if it's a UA framework. So this is not like AI service. This is just to show you in a nice way. This is the chat. Let's go directly to the conversation. I think basically there's nothing more. It's a very simple service. That's the point. Yes.
Sorry, is this the notebook for the agent that we created on AI Foundry?
Yeah. So I can share those after. So we started with this one. The light one had no debugging, no nothing. Create and talk to it. This is trying to integrate it to Gradio, right? So here you see it's a Gradio UI. It's basically the same thing. Let's see if it's running still. I think it's supposed to run. I think I will run it. Let's run all. This one maybe, what we can do? I'll talk to, again, the organizers. Maybe next week we do semantic kernel. There's so much more to do in semantic kernel. This is, again, for single agent semantic kernel, we have more control of the selection strategy of agents, determination. What we do? Huh?
Hello.
Hey, we're late. Close the doors. Nobody's leaving. So here it's campus return on the 30th. I tried to confuse my. So here, this all the code I showed you in the complicated notebook was to show those cool things, right? So it was calling the fetch flight information. Then it tells me this is a price. Yes. But I need hotels. Well, I'm going to Dubai, so Dubai.
Fetching information from database, right?
Yeah, so this was I was saying. So here it's fetching the hotel information. This is the input it's sending, etc. So to answer your question, so this is where you define your business logic. So basically, I'm hard coded here. The information it's sending, but this could be an API to Qatar Airways or Amadeus or service to get the flights. So this is AI Agent Service. So again, start the experiment. It does function. It does RAG. It does all those things. But if you're a code first person and you want to host and you have an environment for hosting your application, this is where semantic kernel comes in. And I'm thinking what we can do now. We're going to just talk about it today. And then next week or when Fatima and the team decide, we can do the deep dive in code and stuff, which is good because I have so much, like I want to do some advanced on the agents communication, etc. So this is just to show you, like we use Semantic Kernel internally. So all the copilots we have are built using Semantic Kernel. So it's a trusted, well-used, battle-tested kind of framework. It's not something we just open source. Again, I recommend you join your the office hours on Wednesdays. I try to join them myself as well. It's 6 p.m. But if you have questions, or it's the PMs, or you can just listen to others. I just like to listen what customers are facing as issues. So basically what Semantic Kernel, again, started as the AI orchestration, right? Like 2 years ago when I started building, I still build sometimes code without Semantic Kernel, right? But you have to do the calls and building the messages and making sure the history is there. Semantic Kernel does all that for you, right? So it calls the LLMs, it does the history, connections, etc. And as I mentioned, like you can link it to Copilot. So I can expose my Semantic Kernel in Copilot or Office 365 Copilot or vice versa. So if I build an agent Copilot Studio, we have multiple, and then you want to do orchestration with them in Semantic Kernel, we have a wrapper for that as well. So we're really trying to make sure they are used overall across all our products. So it's open source. Now we're calling to do agents, but it's basically just another feature. It does more than just agents. So it works with Azure OpenAI. You can do models on Hugging Face, etc. And it's both C# and Python. Any .NET developers here?
Once.
Used to? Me too. I miss it actually. I really like C#. John Skeet. You used to follow John Skeet? John Skeet is like, I don't know if you know, he's like so good at C#, but he used to work at Google, and he's the top Stack Overflow like user. And we tried to compete with him, but he can't. I mean, the guy lives on Stack Overflow. But yeah, it's C#, Python. I haven't seen too much Java, but so basically this is how it looks, like a simple agent also, or code. This is not an agent actually on Semantic Kernel. So I'm just creating an Azure chat completion, which is my service. I give it a deployment name. So this could be O3, GPT 4.1. I can give it the keys or use the credential, the endpoints, what's the version, and the instruction, because I'm using the reasoning model here. And then I add it to the kernel. All of you are like the software engineering. Again, the kernel is just a dependency injection, like to get the services you need and call them. Here I'm showing how we do semantic functions. So as you see here, there's this add function in the kernel. I give it the prompt template, and then I'm customizing it here. I'm giving it the function. What is the function name? And then this is how I invoke it, right? So I just give it the function. I just defined here, and then the text, and I just want a summary, right? Couple of lines I already have. I didn't have to do history. I didn't have to call the LN directly. Here, I didn't tell it which service to call. We will look at the settings later, so I can have multiple services, right? Because here I can have a reasoning model, I can have a 5.4, I can have a fine tune, and I all add them to my kernel. So this is what it does, right? There's so much happening when you think about all those LangChain, semantic kernel applications. So for my application, it selects the AI service for me. It rendered the prompts with the semantic function we showed. We had some kind of templating to do. So it will render the prompt. It will invoke the service to do some reliability, making sure we're doing the right things, templatization, notifying the application, telemetry and monitoring. It will parse the response from the LLM. It will see if I need to call the function, etc. There's a lot of things happening behind something like semantic kernel, which is good. We don't have to think about, right? So first core concept is plugins, right? So plugins, very important for agentic space, because plugins is what will contain my functions. So this is a plugin, what we call here class or whatever. It contains all my functions about onboarding an employee, right? So function calling, I wanted to dig deeper a bit because I think it's just good knowledge to know on what happens. There's a lot of magic or engineering happening in function calling. This was started by, again, OpenAI. So, when we started the LLM, we realized it cannot count, it cannot do strawberry, it cannot do this. So we're like, oh, what if we do functions when we don't know what to do? Which is a good thing. So they retrained the model. So they do special kind of tokens to say when the model decides that it doesn't know what to do, it will generate that token and it actually would stop. It will stop generation of tokens. It will go back to the user. It's like, hey, I need to call function X to do 1, 2, 3. So the app had to do something. So, it's a function call. I need to call the function. Then you call the function, you get the results, and then pass them to LLM. So you add them actually to the history. So all this had to be done if we didn't have semantic kernel. You have to do it yourself. So this is what semantic kernel and a lot of those frameworks do on behalf of us, is that they do this. You make a request, serialize the function. So this is the, when you declare your plugins and add them to the kernel, it serializes JSON to the LLM. We send it in every request. We tell the LLM you can call function to fetch flight information, hotel information, you can book. So all of this is always sent to the model because it needs to know that, I have some functions to call. But it doesn't have the code, right? It just have the JSON and the descriptions. Models do not call code, at least for now. So when you get the output, as I said, either it's a chat response, so I show it to the user, or semantic kernel, or you do it manually, you call the function, you pass it to the LLM. So there is a lot of things that it takes care of for you. So here's an example. So please turn on light 1. Assistant says, hey, so when you say this, the LLM actually stops and returns this. Like, hey, you need to call this function with these parameters. So it does the cool thing with you, the parameterization, but it doesn't do the job. So then the tool is called, and again, the output is sent to the LLM for the final thing. And this is just to show multiple tools. So please toggle all the lights. So it realizes, okay, which lights do I have? So again, come back to me, calling the lights, sending it to the LLM, LLM turning the other function, calling it, etc. So there's a lot of complexity with function calling. It was not an easy thing to do. So what semantic kernel does, again, just to summarize. So when I declare my plugins, or if I use MCP nowadays, so MCP, if I connect to an MCP server, it sends me all the function it can do as JSON. So in my application or in my semantic kernel environment, those JSON that I receive from the MCP or locally in my code will be sent to the LLM. So of course, it does the previous chat history. This is a given. Again, has to parse the LLM response and then decide, is this a function call or just a normal response? And then I think I covered all of this, and it will repeat until you get the completed from the LLM. I really liked how they do the function calling. And then memories. I think somebody asked about memories, but very important. I think this is why, for example, ChatGPT impresses people now, right? Like if you go to a prompt now, it says, hey, everything you know about me, can you draw a picture? I don't know if you tried those prompts, but it's because it summarizes your conversation. It knows about you, what you like, what you don't like, etc. So we have to do the same things. I think our users expect the same experience in ChatGPT. Pretty sure you face this, or your manager's like, yeah, but ChatGPT knows about me. So we have to do this. And this is about memory. So prioritizing, what do we remember about the users? How do we summarize the conversation? So maybe at the end of every conversation, we do a summary, we save it about user X. So we make sure that it's coherent. We make sure we're not cutting things in the middle. As I showed you in the function stuff, why I wanted to dig deeper into this, because it's actually part of the chat history, right? So if you dig into the history of the discussion, you will see function call, function result. So if you do just kind of blind memory saving yourself, you might be cutting in half, etc. So semantic kernel has some smartness that it looks, if it's a function call, I have to do the other parameters, etc. So it's not as simple as, take the last 10 messages and truncate the history. So we have 6 minutes. I think I'll finish the slide. And season 2, we can do the code next week or some other time, inshallah. So this is how semantic kernel looks like in terms of high level, but I wanted to focus on memory. So of course, the building blocks, AI models. We talked about plugins. This is what gives the power to it. Oh, wow, we just started recording now. And memory system, we have short-term memory. Short-term memory is again about the conversation. What if, I don't have enough context? What if the data that it previously talked about is not relevant anymore? So this is about really the current conversation and how do you handle it? Long-term memory could be anything. Could be, I took summaries of, as we discussed, of this conversation and I saved it. So next time you talk to me, I know what you said. Could be the vector embeddings. It could be the RAG. So we support in semantic kernel, of course, RAG is like a key thing. And then, of course, different memory stores. So I can have volatile store, like in memory that I'm in current conversation, or persistent store. So this could be anything, SQL, could be Cosmos, could be Oracle, etc. So I'll talk a bit about this piece because I think this is an interesting one. This one, I think we all know how to do vector embeddings if we did LLM so far. So it shouldn't be very interesting. So again, as I said, so, you're talking to the LLM, things in the top you talked about might not be relevant anymore. It might confuse the LLM. It might not be, you want to save cost because the history will actually be passed. Every time you send something, it will be passed as the prompt in the context. So maybe you want to save cost. Maybe the LLM doesn't support that. Meaning, I think now they're all getting into this million window, but maybe smaller models don't have this. So we have to think about how do I reduce the history, right? So we have 2 ways in semantic kernel to do this. So we have the truncation, which seems to be like the hard code. Okay, just remove anything past 10, 20 message. Even then, it still, as I said, has to be smart because you don't want to cut things in the middle of function calls, etc. You have to make sure you're cutting in the wrong thing, in the right place. And then we have the kind of the summarization, right? So summarization is interesting. Truncation, I guess, is obvious. Again, deleting previous messages, just keep the latest. Summarization is more like what has been said is important, but I just need a summary. I don't want everything. Give me the most important things that were discussed in the last previous message. So this is where the summarization comes in. So every time this kicks in. So when this kicks in is when you have the length of messages greater than target count plus threshold count. So this is mandatory. Question or? Target count is how many messages I want to start deleting. And this is a threshold count. This is important because otherwise it will just start deleting even after 10 or 15. You don't want this. Maybe you stay after 20 messages, start kicking this process, right? So it just gives you a buffer. So every time this kicks in, an LLM, of course, as I said, like LLMs are used all over the place to give you a summary, and then it's added to the context. So instead of having 20 message that you talk maybe just to get your age or your name, it will be like a summary. Name of this person is Ahmed or Khalid, whatever, right? And it will be added. So every summary is added to the conversation. So this is how we deal with short-term memory. 2 ways, truncate or summarize during the calls. So I was going to do a demo here of the intro stuff, but I think we have 2 minutes. Any questions? And then maybe another session. Oh yeah, questions. I didn't have questions. Let me ask ChatGPT. No, let me.
And also just in the, okay, you can think of your questions and I'm just gonna do like